Hi, my name is Will, and I'll be talking about our paper, Dead or Alive, Continuous Data Profiling for Interactive Data Science. As more organizations try to power their decisions with data, it's critical that the analyses, dashboards, and models that they're using are accurate and trustworthy before decisions are made based on this data. However, the main bottleneck in modern analytics is humans, not compute, and therefore the scarce resource for data scientists nowadays is their time and attention. And we see this in continual surveys of data scientists, where they self report spending almost half their time just on data cleaning and visualization. And especially with larger and more data sources, building this data understanding is too slow and repetitive. And why is looking at your data important? Because nowadays it's super easy to train a model, run a hypothesis test, or transform your data with only a few lines of code. However, it can be easy to skip over the limitations of your data because of the cognitive load of checking so many things. And we see this because many data issues are silent. So for instance, if we're trying to train a model to predict the monthly rental price of houses based on this data, we might look at the data and say this looks good initially, and we're trying to predict the price. However, on closer inspection, we can notice several errors, such as duplicate posts in the post ID column, outliers in the price and square feet columns, incorrect values in county column, and many more issues. And these issues are important because analysis often depends on data being semantically correct, which requires human input that the data actually makes sense, but it's still very slow and tedious to check all of our combinations of data to make sure it's high quality. This is important because we want to support data science where it happens, namely in computational notebooks. And computational notebooks have really become the platform of choice for data science because they support iterative exploratory workflows and they rely on a code-first approach to interacting with data. And prior work has explored how can we help people understand their data and quality issues and no-code data tools, and these automate the need to specify charts through code manually. However, they're not integrated into this coding workflow, so they lack the full flexibility of a coding environment. Other tools are actually integrated into the program environment like Jupyter, and they work in Jupyter to provide automatic EDA and visualization. However, many of these tools are not reactive, and they present a lot of information, so there's an information overload for end users. Our goal in this work is to provide continuous data profiling during analysis. And what we mean by this is to really support a fast loop between when a user transforms their data and verifies the result. And our goal is to make this feedback loop as fast as possible by supporting this verify step with automatic data profilers. And our goal here is that faster feedback loops lead to fewer analysis errors and better data understanding. And to do this, we built a system called AutoProfiler. And AutoProfiler supports continuous data profiling with three key features. The first is that it shows initial EDA information automatically. It has live updates when the data updates, and allows users to export code back to the notebook for follow-up analysis. So thinking about showing EDA information automatically, what we mean by this is that AutoProfiler profiles every pandas data frame in memory in the sidebar of the notebook. And this serves as a starting point for data understanding with univariate charts and summaries. This helps accelerate noticing errors and trends in our data. We do this by showing important EDA information about the data frame. So for instance, we show things like the data frame shape, column names and types, distribution previews, and missing values. And if we click on one of these columns, we can see even more information. If it's a quantitative column, we'll see a distribution overview along with extra information like if there's outliers or if it's sorted. If it's a categorical column, we'll see the top 10 most common values and their counts. And if it's a temporal column, we'll see the distribution of the column over time and the count. Our next key feature is that AutoProfiler updates when the data updates. So in this case, we've loaded in a data set about housing called DF housing, and we see the profile on the right. However, as soon as we execute another line of code, in this case, we say we want to filter to the points with a price greater than $5,000, we'll see where the profile on the right updates automatically. If we apply another filter to counties that are in San Francisco, the profile updates once again. We can see this more in a live demo. Here we once again load in this data frame and we see that the data set is loaded in AutoProfiler. We can open a couple of the columns like county and price. And now when we execute another line of code, for instance, the first filter or now the second filter, we see this profile updating instantaneously almost. And this fast iterative feedback gives us feedback as our data updates. So we can see distribution changes and the results of operations immediately without having to change tools. Our third feature here is that we want to allow users to export code back to the notebook. And we do this in two ways, selection exports and template exports. So if we have this distribution of price and I click on one of the bars, I'll have the code for the selection written back to the notebook so I can get the points where the price is in this range. I can do the same thing for a categorical column. For instance, if I want to investigate more about points where the county is San Francisco, I can click on that point in my plot. I can get this selection written in code to my notebook where the county is San Francisco. I can also do this for more complex bits of code and template exports. So in this case, I can click the export button and I can get all of the code written for this chart. So now I can edit this code more if I want to, for instance, change the number of bins or edit it however I please. So we evaluated our system in two complementary ways. The first was a user study, and the next was a longitudinal case study to evaluate the effectiveness of AutoProfiler. In our user study, we recruited 16 experienced Python and Pandas users, and we gave them a data set and asked them to produce a report for a colleague before they used that data to train a model. And they were graded against a rubric of 16 known insights and errors. We had two different conditions in our user study. The first is where users use the AutoProfiler system that I just described. And then the other one, they use a system called Static Profiler that has the exact same visualizations. However, this information is provided inline in the notebook and without automatic updates. And there's three primary results from our user study that I want to share. The first is that both systems lead to similar number of insights discovered, while live profiles make verification easier. The next is that automatic visualizations speed up insight discovery. And lastly is how exports facilitate follow-up analysis and learning. So look at this first theme. We actually see across both versions of these systems that a similar number of insights were found. However, the users using AutoProfiler noted how they felt that the live profiles made verification easier. For instance, P3 said, "It was nice to see when I do the uppercasing, I can just see, oh, that worked. When I do the drop duplicates, I can just take a look and see, oh, that worked." And they liked that. So this helps them verify that the transformations are having the expected effect on their data. Nextly, we look at how automatic visualizations speed up insight discovery. So notably, across both of these systems, 91% of discovered insights came from the tool rather than a user writing the code themselves. As one of our participants said, "I might have known to look for it, but it would have taken me a lot longer to remember how to do it in Pandas." As we see that this automatic visualization, even for simple visualizations like univariate distributions, can really help speed up insight discovery. Lastly, we see how exports facilitate follow-up analysis and learning. Notably, every participant in our study used code exports at least once. As one of our users said, "For the educational perspective, that's something I didn't expect. Specifically, I exported the standard deviation and I could see points inside or outside of 3 standard deviations. When I saw that code, I learned that's the way to do that." So while they're using the system, they're learning more about data science. We also ran a longitudinal case study in which scientists at a national lab used AutoProfiler over a 3-month period, and afterwards we conducted an observation and interviews. We have more information about this in our paper, but I really want to highlight one theme here, which is how AutoProfiler facilitated serendipitous discoveries in their data by plotting columns the scientists might not have thought to plot otherwise, and it helped them generate a better understanding of their data. We've used several avenues of future work for AutoProfiler. The first is how it continues the line of work on how to augment human intelligence with automated assistance. This saves people the cognitive effort of assembling data profiles and lets them spend this on interpreting results, lowering the barrier for data-driven decision-making. We think there's 2 extensions to this that are exciting. The first is more guidance and alerts. For instance, how can we guide users toward unknown insights without notification overload? And the next is more avenues for code authoring for other analysis tasks. The users of our system really like that it could author code for them, so how can we offer extensible platforms for facilitating code authoring? This has been our paper, Dead or Alive, Continuous Data Profiling for Interactive Data Science, where I presented our system AutoProfiler for doing continuous data profiling. Thank you so much.